Hi everybody. We are going to talk in this video about sine and cosine functions and how to make a graph of sine and cosine functions with vertical shifts and horizontal shifts and changes in amplitude and things like that. I already posted in Edpuzzle a video about what each of these functions do. We're going to take a look at it a little more specific here to how you would graph these functions for a physics class. This can get very complex, get a lot more difficult than we're going to make it. We're going to keep it very basic, and this is what you would need to get through to a calculus-based course if you are ending up there. Once you get into the calculus-based course, you have to do some other functions and this gets a little more complex. So first and foremost, we're going to take a look at the terms that we deal with in this, and so you already know that y is equal to, we'll use a sine function. Same thing goes for a cosine function. So y is equal to a sine bx plus c plus d, where the amplitude is going to be a, the vertical shift is going to be d, the horizontal shift is going to equal negative c over b, and the period, which is represented by the letter t, is going to equal 2 pi over b. The horizontal shift is going to be the most challenging part of this. I'm going to talk to you about some ways of simplifying that when we get to the actual graphing. So I'm using the program Desmos here. If you haven't played around with this is a fun program that can allow you to do some very basic graphing, very complex graphing actually, but it allows you to do the basic stuff, which is what we're looking at here. So y equals the sine of x. You can see the graph that appears down here. Now, let's just take a look at what happens when we change the amplitude. So y equals 4 sine of x. What we can see here is that this has oscillated up to, or amplified up to 4 at the crest and down to negative 4 at the trough. It still has the same points where it crosses the equilibrium or the x-axis. And so we are seeing it go at the amplitudes up by a factor of 4. If I change that to a factor of 2, it doesn't go as high. It only goes up 2. So that's your amplitude. See, there's 3. The next function that we want to take a look at, maybe we'll just use the same function and look at the vertical shift. We can vertically shift this up and down. So if I wanted to, for example, shift this upward by a factor of 2, what I can see here is that I've taken the point where it has crossed the 0, 0 axis, and I've shifted it up 1, 2. It's shifted up to 0, 2 from 0, 0. And so that function is just shifting up and down. We could shift it down 2, for example. And so just a very basic vertical shift. The period is going to say, I'm going to jump to period right now. The period is going to say how many times it's going to go up and down in this same amount of time, or how quickly it's going to move up and down. So if I make this, for example, plus 4, or 4x, I should say, 4x, it is, we'll get to the plus 4, I was jumping to the period, as I said. What we are going to see is that if we take this graph, it is going to go, assuming this is our start points, goes one oscillation. In the red graph, it goes 1, 2, 3, 4. Goes up and down 4 times. Two ways of thinking about this is that number, the 4, tells you how many times it goes up and down in the same period. So it goes up 4 times to 1 of the original graph. Or another way of thinking about it is it takes, you can do the inverse of it. You can do the inverse of it, 1 over 4, that it takes 1/4 of the time to do one oscillation. either way you want to think about that. But the period is going to describe the amount of time to go up and down. So your b value over here on the left is a quarter, right? And so the original graph had a b of 1, so it took 2 pi to go up and down once. In this case, it's going to do it in a quarter of the time it's going to take it to go 2 pi. And so, or 4 times in the original cycle, whichever way you want to think about it. The last piece is that horizontal shift. And the horizontal shift is going to be the way that it is going to shift left or right. And so I'm just going to go back to our original function of sine of x. They're sitting over top of each other. And if I put on here +1, that means that my origin point, which is located right here, has shifted back 1 line. It shifts opposite the function. So when we look at our value here, this negative sign, this negative is going to make it shift back to the left. If I do, and that negative sign again is located right there. If we are going to do it -1, it'll shift to the right. Let's look at the red function. It shifted 1 box to the right. And so if we want to take a look at this, we need to remember that we have to flip the sign. I'm going to show you an easy way to handle that. So let's look at how we can graph these functions without using a online graph or some graphing calculator. So let's pick some numbers. Y equals 3 sine 2x minus 1. We'll just do a -1 plus 4. Okay, so we have this red graph. How would I go about graphing that to make it to find the points? There are a couple of ways to do this. We are going to look at one of the simplest approaches, where we look at finding the 5 points that hit the 3 equilibrium points and the 2 amplitudes. So again, let me write the function here. Y is equal to 3 times 2x minus 1 plus 4. And so the amplitude is simply going to be 3. The vertical shift is simply going to be 4. The horizontal shift is going to be -1 over 2, or 1/2. And the period is going to be 2 pi divided by 2, or it's just going to be a pi. Now, how does this this look? So we're going to use our 5 points, 5 coordinate points. First off, I like to put in the y values. So we know that in a normal sine curve, that our graph crosses the origin at the equilibrium points. But our equilibrium point has shifted up, done a vertical shift of 4. So in the normal graph, the values would be 0 here, but in our graph, they're going to shift 4. Now, the amplitude of this thing is 3, which means that from that equilibrium point, it's going to swing up 3 extra values and swing down 3 extra values. So from 4 plus 3 is 7, and then 4 minus 3 is 1. And so quickly we were able to get our 5 y values of our y values of our coordinates for the points that we have, our key points in our sine curve. The next thing we want to do is we want to get those x values, and that's going to be the hard part. We know that the period is going to be pi, which means that, and remember, the period of a normal function is 2 pi. So the standard function is 2 pi, so this is going to oscillate up and down twice in the time that our original function y equals sine x oscillates up and down once. And so the way we can figure that out is we start at our horizontal shift point of a half. That's going to be right here. That's our first point. And then all of our other points are going to be 1/4 of this value further along. So the final value is going to be a half plus pi. This is a 1/2 plus pi. This is going to be 1/2 plus 3/4 pi. This is going to be 1/2 plus half pi. And then this one here is going to be 1/2 plus 1/4 pi. And so you could stick those into your calculator. I'm not sure what those values are actually are off the top of my head, but you could plug them in, get decimals. We like decimals in physics, and you would have your x value. So this value, this x value here, is going to be, again, 1/2 plus pi over 4. This is going to be 1/2 plus pi over 2. This is going to be 1/2 plus 3 pi over 4. This is going to be 1/2 plus 4. Get your decimal values and graph them. With the cosine function is going to follow a similar pattern, but please remember that a cosine function goes like this. This is our origin. It's going to go down like that. It starts at the maximum value, goes to the equilibrium, goes to the minimum value, goes back to the equilibrium, goes back to the maximum value. And so when we're dealing with the cosine function, the y values are a little different. So if this was originally a cosine function, it would go something like 7, 4, 1, 4, 7. Those would be your y values in your ordered pair of your cosine function. And then your shifts would be the same. So if this was,